This Cobb-Douglas function is just showing us the utility we can get. This U represents a utility. Okay. X and Y represent two goods. Okay. So, question A. Derive the Mmarshilian demand functions for goods X and Y. So colleagues, this Mmarshilian demand function is just telling you how much, the quantity of goods you can buy with your income and the prices available. Okay? The quantity of goods that you can buy with the current price and your current income. Okay? Let me just write it down. Mmarshilian demand, the quantity of goods you can buy with the available income and prices. Okay, so we need to derive it. Okay, we need to derive it. So this is how you derive the Mmarshilian demand function. Okay, step one. Okay, get the marginal rate of substitution. Okay, the trade-off rate, how much of good Y are giving up to get good X. Okay, that's the first thing. So if one get the marginal rate of substitution, which we're going to do here. Okay, so we have got our utility function U equals X, Y. Okay, this is X to the power 1, Y to the power 1. Okay, so remember, our marginal rate of substitution is our marginal utility of good X over the marginal utility of good Y. Okay, so we need to derive our utility function so that we get these marginal utilities. Okay, so this is how we're going to derive. So first we get the marginal utility of good X, meaning we're going to derive our utility function, partially derive our utility function with respect to X. Okay, meaning we're only deriving X in this expression here. Alright, so if we derive X, okay, I hope we now all remember how to derive. Okay, when you derive X to the power 1, okay, it gives you 1. Okay, remember this is X to the power 1. You multiply the exponent with the invisible coefficient, which is a 1 here. 1 times 1, you get a 1 there. Then you subtract a 1 from the exponent for X. 1 minus 1, that is 0. Okay, 1x to the power 0, y. Okay, so x to the power 0 is the same as 1, and this one also you don't really need to show it. So when we derive, this is what we get. We just get y. Okay, colleagues, when we derive our utility function. Any questions? Okay, we derive our utility function now with respect to y. Okay, we're deriving our utility function with respect to y. Okay, so this is y to the power 1. We multiply this 1 with the coefficient there, we're going to get a 1. Okay, you subtract 1 from this exponent, you remain with y to the power 0. Okay, so you just remain with an x basically when you derive. Okay, so we've got our marginal rate of substitution. We're going to say here MRS equals MUX over Y. Okay, So the marginal utility of x is y, and the marginal utility of y is x. Okay, so here we're going to have our marginal rate of substitution. We have x over y, y over x. That is the first step, colleagues. Okay, any questions? Any questions, queries? Okay, step 2, equate it to the slope of the budget constraint equation. Okay, step 2, equate to the slope of the budget constraint equation. Equate marginal rate of substitution, MRS, with the slope of the budget constraint line and solve for x and y. Okay, so the budget constraint equation. Okay, let me even just formulate it before we get to the slope. Okay, so let me put here in step 1, get slope and budget constraint equation, because we'll need it, the budget constraint equation, later. So get MRS and budget constraint equation. Okay, so the budget constraint equation. Okay, BC, budget constraint equation, it's the income which equals the price of good X, PX, and the quantity of good X. Okay, this big X here, just this is the quantity of good X. Okay, colleagues, plus the price of good Y multiplied by the quantity of Y. Okay, this is our budget constraint equation. Okay, yes, so the slope of the budget constraint equation is PX, price of good X, over the price of good Y. Okay, also this slope just tells us how many units of X you're giving up to get, how many units of Y you're giving up to gain 1 unit of X. Okay, colleagues, so the first step, get marginal rate of substitution and budget constraint equation, which are here, here, and here. Okay, then step 2, as I said, equate the marginal rate of substitution with the budget constraint equation to solve for X and Y. So this is what I mean. Okay, remember the point of utility maximization. That's what we're doing here, the point of utility maximization, where MUX over MUY equals the price of good X over the price of good Y. Okay, so we already got our marginal utility for X, it is Y, and we already got the marginal utility for Y, that is X. Okay, so we equate this with the slope. Okay, so PX here, PY. So what's going to happen? You cross multiply. y times py and x times px. Okay, so x times px, you're going to get x, you just get px, x equals y times py, you're just going to get py, y. Okay, yes, all right. And as I said, you solve for x and y. Okay, so if you want to make x the subject of the formula, x, you're going to divide both sides by px. Okay, so you have py y over px. Okay, colleagues, I used this expression here to get this value of x. Okay, divide both sides by px so that you get the value of x. All right, then using this same expression here, we get the value of y. To get the value of y, you divide both sides by py. Okay, so you have y equals px over x and pxx over py. Okay, colleagues, this is what we wanted in step 2. Okay, we want to get the value of x and the value of y. Any questions so far? Okay, step 3, substitute your values of x and y. Substitute your values of x and y. Substitute your values for x and y back into the budget constraint equation. Okay. Substitute your values for x and y back into the budget constraint equation. Okay, so our budget constraint equation, let me write it again here. It's your income equals the price of good x multiplied by the quantity of good x plus the price of good y multiplied by the quantity of good y. So this x equals py over px. We are bringing it in here. Okay, so we have px, then the x here we're substituting it with py. Ours is py y over y py y over px. Okay, and you're going to say plus py y, okay, which equals I here. Okay, so we solve this px and this px can cancel each other out, so we cancel these px's out. All right, we're going to remain with py, the price of good y, multiplied by the quantity of good y, plus py y here again. Okay, so you just add these two, py y plus py y, you're going to get 2 py y. Okay, then remember I will have I this side. Okay, so now you want to make y the subject of the formula here, so you divide both sides by 2 py. and say y equals I over 2 py. Okay, this is the Mmarshilian demand for good y. Okay, this would tell us how much of good y we can buy with our available income and the price. Okay, that's the Mmarshilian demand for good y. Okay, then for good x, it's the same process, colleagues. Okay, this px, this y equals pxx over py. We're also going to bring it back into this equation here. Okay, so you're going to have I equals px x plus py y. Okay, so where there's y, substitute it with pxx over py. So we're going to have px x plus py. So y, remember, y equals pxx over py. Pxx over py. Okay, you cross these out, you're going to have pxx plus pxx. Pxx plus pxx, you're going to get 2pxx. Okay, and you have I on the other side, so you get the value of x. Divide both sides by 2px and then let's see, x equals I over 2px. This is the Mmarshilian demand function for good x. How many units of good x we can buy with this income and this price?